that you know how to take off and land safely, we need to learn how to get where we're going in between. Most real-world missions will have preloaded waypoints to guide you, but for the remainder of this section of the course, we're going to practice our data entry skills by manually entering waypoints into the navigation system. This serves a twofold purpose. First, it forces us to become familiar with the data entry process and various GPS coordinate formats, and second, it gets us ready for the true purpose of GPS data entry, precision bombing. Of course, we're not quite ready to start dropping bombs just yet, so we'll have to settle for flying between waypoints. For this afternoon's flight, we're going to go visit the ground attack training range so you can become familiar with the area. We're obviously not going to get much accomplished cold and dark, so go ahead and get the aircraft started up and we'll learn how to enter waypoints.
Roll left, roll left. Flight controls, flight controls.
Okay, let's get started with some data entry. I find that it's easiest to use the right MDI for data entry because all the buttons you'll use the most are located close together, but it's up to you. Do what you're most comfortable with. Also, you should be getting pretty familiar with the cockpit by this point, so I won't be hand-holding you with individual button presses anymore. You'll remember where everything is a lot better if you have to look for it yourself. In order to let me know that you've moved on to the next step, I'll ask you to press the IP push button in the top left of the UFC panel to signal me that you've completed the last instruction provided and I can move on to the next step. Let's test that out now by pressing the IP button. Perfect. The first thing we need to do is get to the data page of the HSI. Go ahead and open up the HSI on one of the MDIs and then press the push button for data. This is where most of the work is going to be done today. As you can see, there are a set of coordinates already listed on the screen. This is the current location of the aircraft, which is listed as waypoint 0 by default. Although it isn't strictly required, we're going to go ahead and get into the habit of adding waypoints to sequence 1. Alright, now that we've added waypoint 1 to the sequence, we need to actually put coordinates in. There are 4 types of coordinate systems we'll be learning today: lat-long normal, lat-long precise, lat-long decimal, and finally MGRS. The first of these is the simplest, but also the least accurate. Lat-long normal is great for general navigation waypoints that don't require pinpoint precision. They consist of a simple 6-digit number that provides latitude and longitude in values of degrees, minutes, and seconds. For example, our first waypoint is North 41 40 43 East 45 29 06 2,451 feet. The first letter of each line indicates the hemisphere of that 6-digit coordinate. We're in the north and east hemispheres, or northeast hemisphere. The first pair of numbers tells you what degree of latitude or longitude you're at, the next pair are the minutes, and the last pair are seconds. What does that mean to you in the cockpit? Not much, honestly, but that's how maps work. The last line is the elevation at those coordinates in feet, which isn't really required for navigation, but is critical when dropping ordnance for precision strikes, so we're going to get in the habit of entering that information every time we deal with GPS. The aircraft likely started in decimal mode, so we're going to have to switch that before entering the code. Press the A/C button to bring up the configuration menu. Then if you see lat-long decimal in the bottom right, press it so it changes to lat-long seconds. Then go back to the waypoint screen. To enter the first waypoint, first make sure you're on the correct waypoint by pressing the up and down arrows to select waypoint 1, then press the UFC push button. Move over to the UFC menu and press the POSN button. To enter the coordinates, you first need to tell the UFC which hemisphere you're entering, and the 2, 4, 6, and 8 buttons have direction indicators on them that you press before entering the 6-digit coordinates. So to enter the first line, you press 2 for north, then type out 414053 and press the enter key. Now press 6 for east and enter the appropriate 6 digits for that coordinate, 452906, and press enter. Lastly, enter the elevation information by pressing the ELEV button, typing in the value provided, 2451, verifying that you're using the correct unit of measurement, feet, and pressing enter to store the waypoint. Not too complicated, but also not very useful for anything but navigation. If we're going to drop bombs using GPS, we're going to need something quite a bit more precise, and this is where the first of the precise modes comes in. To use this, we need to put the system in the correct mode by pressing the precise push button at the bottom of the display. As you can see, the simpler coordinates we were looking at a minute ago just got a bit more complex, but for a good reason. This allows us to get pinpoint accuracy by splitting up the normal coordinates, which cover a much larger area, into smaller chunks by using decimals. The process for entering these is exactly the same as before, except for one additional step, but before we can get to that we need to remember to add waypoint 2 as part of the sequence, so press SEQUFC, INS, 2, enter. Then be sure to it. All that's left now is the remaining decimal. For more precise modes like this, which include decimal space, the decimal values are entered on a separate screen from the main coordinates. So for this example, we typed in N415210 and pressed the enter key, which brought up the HDTH page. Simply type in 90 and press enter again to complete the entry. An easy way to remember this is to replace the enter with dot or decimal in your head while typing the coordinate out. The waypoint display should now show the full coordinate information for the first line, but still 0 for the second. Go ahead and type in the second coordinate the same way as you did the first, then be sure to add the elevation information in the correct unit of measurement.
If you entered everything correctly, your readout should now be N415210.90, E452311.53, 5,408 feet. If it isn't, give it another shot by repeating the steps and paying a little more attention to detail. Tap the I/P button to continue.
As before, let's add waypoint 3 to the sequence, then advance to waypoint 3 with the up arrow. Once that's done, switch back to the AC page and toggle back to lat long decimal so we can try that version. This works pretty much the same way, except that it's a bit shorter and has more digits behind the decimal. Be advised that any single number in what is supposed to be a pair of digits should be entered with a 0 before it, so in this case you should be typing in North 4206 and then enter. And as before, enter the decimal portion. This time it's 3 digits instead of just 2. Once that's done, repeat the process for the east coordinate, then enter the elevation as usual. Okay, now for the weird one. MGRS uses a grid system to set coordinates, and it has a unique user interface to make it work. Get waypoint 4 set up as part of the sequence and advance to waypoint 4 so we can try this out.
Press the UFC push button on the MDI, then press the grid option.
Using the throttle control designator, either using the appropriate keybinds or the controls on your stick, move the cursor on the display until it's over the square, then press the TDC select button. Once you're back on the coordinate screen, type out the 10-digit coordinates provided and press enter. Ignore the space between the 5-digit blocks, they're placed there for readability. You enter all 10 digits on the same screen. Note that if you're unable to enter all 10 digits, the system is not in precise mode. Be sure that's boxed before entering the coordinates. Your display should now read as follows. North 4148.9349, East 4450.6444, 38 TMM 87049293120 feet. Go ahead and enter the elevation information as usual, and this waypoint is finished. Almost ready to fly now. We need one more waypoint to get us back to the airfield, and you're going to enter that one in all by yourself. You can find the information in the mission briefing or kneeboard. I will give you a few hints, though. Remember sequencing. Which waypoint is this? Is precise required for this format? Which lat-long setting on the AC page is required for this format? Okay, hopefully you got that right. We'll find out if you make it back to the airfield without getting lost. Press the HSI push button to go back to the HSI, then be sure to box the waypoint button, set waypoint 1 as the active, and activate sequence 1. Once that's done, go ahead and taxi to the active runway and take off. Climb to an altitude of 10,000 feet and maintain a speed no greater than 350 knots. After that, it's up to you to get yourself back to the airfield. Good luck.
Flight controls. Flight controls.
Colt 1, request takeoff.
Welcome to the training area. You're going to spend quite a few lessons over here practicing your air-to-ground skills, so take a look around and get familiar with the landscape. Waypoints 2 and 3 will take us straight over the primary range, then we'll head toward waypoint 4 to line up with the runway at Vaziani. This marks the eastern boundary of the active range. We'll cross directly overhead and then turn south toward the airfield. And that's the range. Bet you're looking forward to dropping some ordnance. While we head back to the airfield, let's talk about the full Case 1 recovery procedure. What we practiced this morning was the bolter/wave-off procedure for landing on the carrier, which is actually part of the tail end of the Case 1 recovery when a pilot doesn't make the landing. We did it that way because it allowed you to practice the hardest part of the pattern over and over without having to leave the airfield area and come back. While you'll likely be doing wave-offs and bolters a lot once we do it for real, we need to learn the proper procedure to execute a carrier landing. For the remainder of this course, forget that you ever heard the words straight in landing. The last part of an approach to the carrier requires you to perform an initial pass to the right of the ship to confirm the deck isn't fouled before conducting your braking turn to the left and entering the downwind. We're going to simulate that for every landing from now on so that it's second nature by the time we relocate to the Stennis for carrier quals. Once we reach waypoint 4 and begin our descent toward the runway, we'll do a quick rundown of the procedure and you'll give it a shot as we go in for the landing. Let's quickly go over the procedure for the Case 1 recovery, as it isn't very different from what you practiced this morning. As you approach the airfield, slow and maintain 350 knots, descend to 800 feet AGL and line yourself to the right of the runway far enough that you can look down and verify that the runway is clear. After that, it's pretty much the same as what you did earlier. Once you're past the runway and begin your turn, allow yourself to descend down to about 600 feet and then do what you did before. Don't forget to switch back to the radar altimeter to get your AGL altitude. Get us on the ground and back to parking spot 1, then shut down the aircraft and we'll be done for the day.
Altitude. Altitude.
You're about a mile out, so execute your brake turn, but this time allow the velocity vector to slip just below the horizon so you can enter the downwind at about 600 foot h. You should be about halfway through your turn at this point. Don't forget to lower your flaps and landing gear once your airspeed is below 250 knots. Level out at a heading of 310 and get your aircraft stabilized with the velocity vector on the horizon. You're a little right of the optimal downwind trajectory. Adjust to the left until you're about a mile from the runway. Keep your velocity vector on the horizon with pitch trim and bring the E-bracket down to it with throttle adjustments. Try to keep the aircraft at around 600 foot AGL. Looking good. You're within the downwind corridor, so focus on keeping the velocity vector on the horizon with pitch trim and bringing the E-bracket down to it with throttle. Try to stay around 600 feet AGL and maintain a heading of 310. Okay, begin your turn toward the runway when you're ready. Remember to add power and wait at least 90 degrees before looking at the runway. Start visually lining up with the runway and get the velocity vector and E-bracket on the numbers. Remember that you have to keep that throttle moving to stay ahead of the aircraft. Good trap. Exit the runway when able. Head back to parking spot 1 and shut down the aircraft.